Hello and welcome back. Today I want to talk about a particular problem that I want to try and solve. As I start gaining more and more things, it's becoming harder and harder to quickly prototype stuff. So I have resistors and LEDs and chips and whatever pretty much all over the place. It has to be in storage or else I won't be able to find it. It has to be organized again because I won't be able to find it. But that means it also takes me longer to prototype something because I have to go and in like 20 different bins to find 20 different objects that I need. So I want to have a bin, maybe like this. This one here is from the dollar store with all these compartments here. And I want to fill these compartments with the stuff I use the most for prototyping. So I'm probably going to have a few jumper leads, a few components, some different stuff. And today I'd like to start with LEDs. Now, LEDs in particular because I use LEDs a lot. They're very visual for you guys. You guys get to see the output of something, whether it's high or low. And I mean, I've got a bunch of them. I bought 1,000 of these white ultra bright LEDs a long time ago. And as you can see, I've wasted so many, but I've barely put a dent in this thing. So today I'd like to get some LEDs ready to use in Breadboard. Now you might be thinking, yeah, okay, so what's the big deal? You just take the LEDs and you put them in the breadboard, right? Well, the problem is if you breadboard something with an LED, that means you also need a resistor. And if you have a resistor, that means you have to take a couple slots in the breadboard. And again, it's difficult for you guys to follow what is part of the circuit I'm trying to show you and what is part of the LED. So I figured that today I would show you a trick that I've picked up from Julian Eyelet, another YouTuber. Probably going to link to his channel in the description. And I'm going to add a resistor to one of the legs of the LEDs. I'm going to do a few of them. And so I have LEDs at hand, ready to go, ready to put in a breadboard. So I'm thinking I'm probably going to put it in the positive leg and use this red heat shrink, which barely fits over the resistors. But first I need to figure out the value. So like a lot of electronics enthusiasts, I got a kit of something like, I don't know, 70 some values or 60 some values. So I only have about 10 to 20 of each value of a resistor. However, for individual projects, I've been ordering the resistors I need. So like 150 ohms, for example, I have this bunch that came in the kit, but I also have this bunch that I ordered separately. You can buy 100 of them for under $1. So I'm hoping that one of these values, 150 ohms is one of them, will be good for prototyping, and so I could use 150 ohm resistors. Now theoretically, 5 volts through 150 ohm resistor is, well, let me just grab my calculator and do the math here. So 5 volts divided by 150 ohms, that should give us about 33 milliamps, 0.33, yeah, 33 milliamps. So it's a bit high, but I think that's acceptable because I actually run these things without any current limiting at all. And since their forward voltage is actually 2.5 volts, technically you should be doing 2.5 divided by 150, so about 16 milliamps. So I think we should get about 16 milliamps out of this, but I'm going to give it a shot right now. So this is going into the positive here. I'm going to run this resistor into the negative. Let's say here. I'll put it right there. And now let's run this LED here. 1 and 2. And that's pretty bright. Let's check the voltage drop. Here we go. Check the voltage drop on the LED. The LED itself is dropping 3 volts, and the resistor is dropping the remaining 1.9 volts. So the current in here, if I'm not mistaken, should be 1.9 divided by 150 ohms. It should be about 12 milliamps, and we can check that by putting this in milliamp mode, like that, splitting these apart like that, and there we go. So 12.64 milliamps. So we're not overdriving this LED, and I think that'll be perfect. So let me get set up. I will bring the camera a little bit higher up for you, and I'm going to solder these resistors directly onto the legs of these LEDs, and that should be good for prototyping. So I have my soldering iron going. I'm going to use about 350 degrees Celsius to solder. I'm going to see if I'm going to be able to do this here, but basically I'm going to cut the leg right above the knuckle there where the little flat is. I'm going to cut that there, and hopefully I'm going to be able to solder a resistor on very tightly up on that leg, and then cover it with heat shrink and sort of trim it to length. I don't know how I'm going to do this. You guys are witnessing this as I do this on the first time here. So I do have some sticky tack, like the stuff you use to hang up posters when you don't want to get your mom upset. Remember that when you were a kid? You had to be careful on the walls. Okay, so that there. How's the focus for you guys? I think it's good. So I got some of that there. See if I can put another blob over here and sort of hold the resistor in place. I want to keep this straight. As long as that resistor is touching, which it is. Let's see if I can flow solder in between them now. Going to give that a second to solidify, and if that works, then I'm just going to trim all the legs. I'm going to do them all one after the other. Alright, so let's see if we can peel this out. The fact that I can peel it from the resistor is a good sign. So there we go, that's our 150 ohm resistor. I'm just going to trim the other leg flush with this one, like so. And so now we have 150 ohm resistor soldered onto the leg here, and that means that I can now probably just drop that into the breadboard without any issues. Let's see here. I'm going to chop this, chop a piece of heat shrink right at the length I want, right at the bulb of that resistor right there. Cut that like that, slide this over. Sorry if it's out of focus because I'm a little bit closer. This heat shrink is very tight on the resistor, but that's the way I wanted it. Hopefully I can slide it on. I'm going to bring it all the way down Come on. There we go. Bring that flush to the LED. Now I have my heat gun to cinch that down. The lights might dim when this comes on because it is a heating element, which is PWM controlled. And there we go. Finished product. Now it's just to assembly line this. So I think I like the way this turned out. I took the positive legs off and I used red for heat shrink, and that's the color of the positive leads usually. So let's get going and do a bunch more. If this gets way too boring, I might cut a bunch out. So I'll set myself up to cut here right at the knuckle. Got to be careful when you're doing this because those legs want to fly everywhere. And obviously if you cut the wrong one, it'll be harder to tell which is which when you're breadboarding. And the point here is to make things easier for myself, not harder. So I think making 10 of these should satisfy my needs, considering these things are so cheap, and I typically like to leave things in breadboard form for long times, so I just keep buying more breadboard. It's just so convenient. You go back to your old designs, you can modify them, you can use parts of the circuits for other stuff. Is that all of them? 2, 4, 6, 8, 9. Yep, just gonna get rid of the legs. Alright, there we go. Now to do the resistors. Just going to cut them tight onto the lead here. I'm fairly confident in my soldering skills that I'll be able to get these things to work. So I'm trimming them quite close. There we go. So that's done. I'm going to pull all these out. Alright, set this down into the soldering station. Actually going to narrow up this glob a little bit. And then drop this guy in. I think the hardest part here is getting the up and down direction lined up. If there's an air gap between the two, the solder won't flow as well. I guess I could have built a jig to do this, but then I would have had to build a jig. And really I only need 10 of these, so I don't think a jig is necessary. In case you guys didn't know, also the typically the smaller part, I don't know if you can tell, but the smaller part of the LED there, the one that doesn't look like an anvil, is the positive of the LED. I know for a fact that it is on these specific LEDs, but there are some that they make the leg a different length. Sometimes they put the negative leg as the long leg, which is not great if you're expecting a standardized leg layout. This is actually going fairly quick. If it goes quick enough, I'll leave the entire video intact. If it's not so quick, then you're seeing it fast forwarded right now, or you're seeing some parts of it fast forwarded. If you guys haven't seen Julian Eilett's YouTube channel, highly suggest it. He's British, so he has that funky accent, which everyone loves. Plus, I think he's been doing electronics for a very long time, so he's got a lot of old school knowledge, which is amazing because that's kind of like the basics, right? That's the beginning. It's good stuff to learn. He's also very good with Arduino. Mind you, he's very good, but he uses a lot of libraries, which I would say is a good denotation of intelligence. If you're an engineer and you have to, let's say, create something like a power supply, you wouldn't spend your salary designing a power supply from the ground up if something that suits your needs already exists, right? That's sort of like us as hobbyists and libraries. Yeah, you could bit bang your way to success. You can use software that you've written to drive stuff, absolutely. But if time is of the essence, like someone like me who has well, I guess I don't have a full-time job anymore, but I have 2 part-time jobs where time is precious, then you would start with libraries and work your way backwards. Right? If something already controls the Arduino in the way you want it to, you could use a pre-made library instead of building your own. There's a time and a place for building your own, for sure, but when you're testing out new stuff or when you're prototyping, checking out concepts, that's not the time to spend all this time building a library when you're not even sure if it's going to do what you want it to do. I think I've got a pretty good setup here. It's going pretty quick. Just need to shove that aside a little bit. I'm not too worried about the mechanical hold of solder either. It's okay really for what we're doing. The big deal is to use lead solder. If you don't think you know how to solder, if you've tried, it's just not working out for you, make sure you're using lead solder, 60/40, with the flux inside. Makes a big difference. I used to think I was no good at soldering, although I could do it at work just fine. For some reason I kept blaming my equipment at home. It wasn't my equipment at all, it was my consumables. My solder was lead free. It's a lot harder to solder with lead free. Alright, let's trim the ends here. I'm just going to line up the end with my snips. I might pause for the oh, I need a demagnetizer. These things are magnetized. I might pause the video for slipping the heat shrink on because it seems like it's going to be a little bit challenging to get all the heat shrink on. I have heat shrink that's a little bit bigger, it'll fit better, but I want it to fit quite tightly. This and like this. Okay, I want approximately this length here. I don't know what the best way to do this is, so I'm just going to wing it. It's okay if the resistor sticks out a bit. Oh, whoops, I want this length. Hope that's the length I've been using. You can always trim back a little bit. Hopefully, am I still in shot? Yeah, I'm still in shot. I'm well aware this is not the most riveting video you've ever watched, but you know, this is the stuff we do in our spare times. We make our hobby easier, more enjoyable, or whatever. It's all part of it. 1, 2, 3, 4, 5, 6, 7, 8. One more. 9. All right. I'd like to push it in with my finger, but I know when I get to the end it's going to stab me. There we go. Also, the heat shrink adds a little bit of stability because the lead on the resistor is quite a bit weaker than the leads that come with the LED. Also, I apologize for my giant gorilla hands if they get in the way. It's I guess 13 years now of working in the trades. Means I don't have as much dexterity in them as I would like. They're not as steady as I would like. I'm supposing the focus is not as good as I would like because they're quite big. That. Ouch, see, I stabbed myself. It's alright. 'Tis just a scratch. Maybe I should turn my soldering iron off since I think we're done with it. This one is a little jaggy there. I don't know if you can see it. I'm just going to cut it off just in case it permeates through the heat shrink when I shrink it down. This is actually going a lot quicker than I thought. Thought I'd be doing this for ages. When I don't know what to do down in my little work area, I try to do infrastructure projects. I've done a whole bunch, but a lot of them is not filmable because it's not really organized the way I want it to, or it's probably like nothing you'd be interested in, like putting up shelves. But this is pretty cool. I think you make little purpose-built LEDs, and I think that's pretty cool. Stop moving. Gotta get the heat gun now. Sorry about touching the mic there. How am I gonna do this? I guess one at a time. There's a lot of units. Oops, I put the heater out. Careful with that. Ouch. This is really garbage heat shrink. Just ran something out from eBay. Right, should get myself some, this 2-to-1 that shrinks half the size, half the original size. I should get myself some 3-to-1, so it shrinks a lot further. But okay, that's that. So now let's take these back to the breadboard and see if they all work. And here's the finished product. I jammed all of the negative side in onto this rail here, and I put all the positives down in there. They should be nicely nestled in there. This is just about the use case I was imagining, would be to just put them in, and they look a lot cleaner than having a loop of resistor there. So I'm going to come grab the positive here. I jammed a pin header into here, and so I could just slide this DuPont connector along and I should be able to light them up. Yeah, so there's one there, there's the other one, 3, 4, 5, 6, 7, 8, 9, and 10. So they're all working. There we go. They're all working, doing their job. They're all done, and that only took really a few minutes of time. And it should save me quite a bit of time and quite a bit of ease on the breadboard. So I'm just gonna pop these into my box right now. I have 10 of these, and if I need more, I can make more because I have a few hundred left of these, and I have about 100 or a little bit less than 100 left of these. I can always order more. I can make thousands of these if I want to, and it won't be that expensive. Now, as for other stuff that should go in here, I do have a couple things I want to add to this kit. So stuff I use a lot would be these switches here. They are just slide switches. There we go. Double throw, single pole. I'm going to put a few of these in there. I have a whole bunch from another kit. So there's a few of those. I probably want to put some pin headers in there. So I did get some pin headers on the breadboard, so that's going to go into here too. Probably want to put some of those. I have some tactile switches which I might add a little bit later because they're a little bit far away from me right now, which again is why I'm doing this. But I have other stuff too. I have these kinds of switches, micro switches. Might use a pair of those, put those in there. And I think as I make more videos, I'll just keep adding to the kit and update you guys every once in a while with what's inside this kit. So that's it for now, but I would like to know if you were to build a easy access kit like this, what would you put into it? I know I need some more some wire jumpers, but those aren't too bad to get because I purposely put those closer, but I've got to be forgetting some stuff, so let me know what you think. Thanks for watching.